Well, last keynote of the conference, after lunch, no coffee. I like that they're giving me a challenge. So one of the things I wanted to do is highlight a hypothesis. And my hypothesis here is that the Internet of Things, IoT, is basically a keystone for digital transformation for all of your organizations, whether they're public sector or private sector. It takes a bit of everything. It takes a bit of the cloud. It takes communications. It's going to take application. It's going to take transformation of your businesses. And what's really interesting about it is we will see physical challenges and changes across Canada that will look different as a result of the Internet of Things. So I was going to go through a run-through of a whole bunch of industries and a whole bunch of specific use cases. And I bring up use cases because for IDC, it's a very helpful way to think through what technology and what process changes you guys may have to do to actually get digital transformation, to actually bring the Internet of Things alive in your company. And why we stack up this pyramid, this classic kind of management consulting pyramid in this way is your company's industry mission, why do you exist? Some companies have done a really good job of defining this. Back in the 80s and 90s, Microsoft had a computer on every desk, in every home, running Windows. And you think about that, and it lets them stage all their priorities, all the programs, where they're investing, how they organize their entire company, and where do they go from there. And then you think of not just tech companies, but also companies like Walmart, right? Walmart's job is to help consumers everywhere go about their lives the lowest possible cost. And everything operates from that. Where do they put their locations? In low-cost environments, near roads, so they have easy transportation. They invest in their supply chain. Everything flows downwards from that industry mission. And what I'm going to suggest is, when we think about how to actually achieve those priorities that will get your mission done, you're going to have to look to business cases. So that useful definition will come back a couple times in the presentation. Everybody also has their own maturity model. This is ours. You know, everybody's got one. Just when you think about the classic people, process, technology, we like to add a couple more elements to it. 3 not being enough, we need a little more complexity. One is vision. If you don't have that executive support, and the executive support means not just your CEO and not just lip words or being mentioned in the quarterly statements, but also the ability to define people's metrics, how they get paid, what the bonuses are. All those types of structural changes, that comes from vision. The other component is it's different now. Data is an asset. Data is actually on people's spreadsheets. It's on how they measure their company's performance. We've aggregated that to it as well. So this 5-part maturity model will play out in terms of how the Internet of Things comes home in your particular industry. So I'm going to run through a couple different industries here. First off, what's the future of retail? So yesterday was Halloween. The timing was wrong. I should have been yesterday. But it's actually terrifying, right? If you are a brick and mortar retailer and you look at the last few years, it's basically like Halloween at a graveyard. It's terrifying. And even more recently, we think about this. So the future of traditional brick and mortar retail has been overwhelmed by e-commerce, by the rise of Amazon, by changing customer behavior, by legacy investments. But on the other hand, what's really fascinating to me is all of those e-commerce vendors are now thinking about putting their feet in the real world. So when you start thinking about how digital transformation is playing, sure, you look at legacy vendors, legacy organizations struggling, but you're also seeing these new titans of the future, like Amazon, putting their feet into physical stores. And in this case, not only is it self-checkout, their goal is to have a peopleless retail environment. So they're using scanners. They're using HD video cameras to recognize whether you've picked up any of the assets in the store. So if you reach over and got bananas or yogurt, it knows whether you've added that to your total in your bag. So there effectively will be no cashier. Right? The only people who are in the store are there to help load things, and the goal at Amazon always is to get the people out of the job, so eventually that will be a robot instead. So Amazon's here, and you're like, okay, Amazon's a multi-billion-dollar company that's sucking the oxygen out of every industry we can think of. But then there's companies like Indochina, which is a Canadian fashion company. They've gone from being entirely e-commerce, online, and they realize that people like to have an actual tailor fit them for their suits. So they have pop-ups in lots of malls now where you can get measurement, and then the suit comes in the mail later. You look at Warby Parker, who makes glasses. They realize that people like to actually try things on. It's no good buying 5 at a time and sending 4 back. So they have pop-ups. And again, they were a classic e-commerce. But the difference is they are using all sorts of digital transformation use cases. Now, I know this is an eye chart. I'm not going to walk you through it. There's too many. But if you think about your priority, right? We have priority programs and use cases. Omnichannel. Classic buzzword, but basically it means you can buy what you want, where you want, when you want, right? You can buy it on your phone, you can buy it in the store, and the experience should be fantastic either way. If you want to do that, if that is your priority to get to your mission, you need to invest in a whole bunch of things. Same thing goes for supply chain. If you want to have real-time, just-in-time supply chain, you need to invest in specific use cases. So how much of the future of retail is IoT? A lot, right? The investments are all going to be sensors that are connected back to your systems of record in order to be able to drive actions and process change by your frontline staff. And so traditionally, brick and mortar stores, if you think about the comic here, have actually been terrified of technology. But if we bring Wi-Fi in, what's going to happen? They're just going to buy it on Amazon for cheaper. They're just using us as a change room, which, depending on your store, may or may not be true. So there's been a fear of technology in the retail environment about how it affects the user experience. But what I'm seeing is that this is how brick and mortar retailers will turn into click and mortar retailers. That's the difference. What will happen is they use that Wi-Fi experience, whether it's Cisco Meraki or any of the other technologies, they are getting a sense of how many times you have come to that store. They know your IMEI on your phone, right? You don't even have to get into their app. They know who you are because you always have your phone on you. Because who here doesn't bring their store if they go to a mall or any other store? You're going to have your phone on you. And that little phone is a beacon of personalization. They also use all sorts of sensors in the store now. And that tracks things like how long have you been waiting before an Apple store has reached up and talked to you, right? They have metrics for that. And then there's things like, should we be worried about the customer wait time? Should we change our flow? And then you think about Amazon. When you go to Amazon's website, they are tracking almost every detail your mouse does on a desktop or laptop or on mobile. They're tracking what your dwell time is. They know exactly how long you're hanging out on each SKU that you're potentially going to buy. They actually know where your mouse has gone. Is it on the picture? Or is it going out to people also bought this? So you're thinking that's huge data advantage if you're in retail. Well, what's interesting is now with digital, you can track where people flow through your stores. Should you reorganize your assessment and your inventory management to get people all the way to the back? So if you're, say, your superstore, the Loblaws chain, should you put the pharmacy at the back? Because if you go to a pharmacy, you have to go to the pharmacy. And therefore, you can run people past the expensive stuff or past the liquor where your profit margins are higher. So you can better design the lobster trap to maximize your profit from each one of your customers by doing heat maps and path analysis. That's IoT. So you're like, okay, what's this doing in a retail store? I wanted to take you through a journey. How many people here have had the beef since you've come to Drama? I'm assuming most people in the room have probably had steak once or twice. It's been at every meal, it seems. So one of the things to think about is, since the rise of mad cow disease, every cow in Canada that's produced for cattle, for beef consumption, has had to be chipped. Because we need to know if there's an outbreak of BSE, of mad cow disease, what farm did that come from? What stock plant did it go through? What slaughterhouse might be contaminated now so we don't all get prions in our brain and slowly go mad? And what farmers, who are actually no slouches when it comes to optimizing technology, what industrial farmers have realized is, once you have to do the equipment for tagging the cow, why not stick on more sensors? So what can you do with the Internet of Cows? Well, you can do things like, is the temperature of the cow too high, which might mean it has an infection. So then you give it antibiotics. You're not giving the antibiotics just because it's every Tuesday. You give it when it looks like there might be infection, which means that we have less MRI, multi-resistant infection diseases in Canada, right across the country. But you can also think about pregnancy. You can schedule when your farm hands need to go out, bring the mare back so it'll actually have it'll actually deliver. All these things are possible now. And then you're like, well, how are we going to get that delicious steak back to my table? So he's going to take a truck, right? And truck, again, you don't think of it as being a high-tech environment. Farmers, you don't think of being high-tech environments, but they have self-driving John Deere and Caterpillars now. What about truckers, right? We all think of like the classic kind of CB radio. Truckers are a highly technological environment. They have used telemetry for years now. When we think about how vehicle telemetry works, the actual long-distance truck hauling company is one of the places it started. Think about FedEx, think about UPS. They have basically brains moving in real time. They had Google Maps before Google Maps would have been cool. So when you think about how this plays out, not only do you know that your steak is safe because there's cold chain in the back, so you know the blast freezer is working, and you don't have to throw out that load of steaks or potentially kill a whole bunch of people at a restaurant, but you also know whether your driver's safe. So suddenly you get augmented benefits. It's not just about hours of service, which is the new regulation coming into effect this year in the US. So hours of service means, is the person falling asleep at the wheel, basically? Have they driven more than 7.5 hours? And in Canada, it'll come in 2018 as a new rule for that. But you can start saying, well, we've got this telemetry data. What can we do with it? And all of a sudden, what you can do with it is you can decide, which are my worst performing drivers? Not the slowest. Who are the most expensive drivers? Who are the most likely to get into crashes? then I have higher insurance claims. I don't want to pay insurance premiums. So if I see that he's accelerating fast, decelerating fast, then I'm going to probably have to note that in the driver's file. We will encourage the driver and nudge the driver to be a safer, better driver. If you think about the cost of diesel and gas has been expensive. Who's the most efficient driver in your fleet? Why can't everybody drive like that guy? So all of a sudden you have nudges digitally coming to the driver. In fact, there's now actually cameras on most trucks that are going to come, not just to look at whether you're in a crash, which is incredibly important. The dash cam videos are cool because it saves you insurance. Not my fault, they cut me off. They actually flip the video cameras and have ones on the inside to see if the driver is nodding off. So all of a sudden, you are instrumented, not just the truck, right? So you have the Internet of Trucks. Okay, now we get to our local store. If you're in Ottawa, it might be Farm Boy. In Toronto, you've got Longo's. It could be any of these stores. And we think, it's not that sexy a space. But it's actually one of the biggest, most popular retail environments. And when you think about it, Amazon didn't buy Whole Foods for nothing, right? Suddenly they have a whole bunch of very, very loyal customers who will go to a large warehouse-like object all the time. And hey, look, they can pick up their other orders from Amazon Prime at the same time, right? But this is now instrumented as well. So when I think about how a retail superstore is going to be instrumented, there's so many ways you can think about how to optimize this space. Something like 32% of all the energy in Canada is consumed by buildings. So when you think about that, it's heating, cooling, lighting, powering things like fridges and such, 32% of all the energy in Canada. So if you can drive 2% savings on your building management from HVAC, that's worth it. You can prove that your fridge was cool, so it wasn't your fault if anything spoiled. You know when to rotate stuff. If it's, say, it's ice cream, well, ice cream is a high margin, high profit food. But if people find out that it's crystallized, they'll be very unhappy, and they're not going to come back from a Haagen-Dazs from your store, right? You can also start thinking about out of stocks. Something like 4% of retail margins are determined by out of stocks. And what happens is every time you have an out of stock, I go to the store and I want that Haagen-Dazs, it's not there. I will buy it somewhere else, and I will buy everything else in my groceries. That other $125 I'm going to spend at the groceries that week is going to be from the other store. And you will lose me as a customer when you're out of stock. But by having digital supply chains, you won't be as out of stock as often. Okay, so this is all physical retail. We're all pretty familiar with this. And it's not that exciting. Like, we can kind of think through the logic of this. But what's next? So this is Staples Center. This is where the Clippers, the Kings, the Lakers, they all play here. And they've moved to digital signage. Digital signage is pretty popular. Bunch of reasons why. You can change it instantaneously. You can use it for crowd control. You can change it up if you have a different tenant every night. And you have totally different themes for each one. That's not why they're doing it. So they know what the time is versus when the crowds are coming, because they have crowd control and they have monitors for roughly what proportion of the crowd has arrived. They know what the temperatures are, so they can predict what people are in the mood for, and they know roughly how many people are going to attend. They have variable pricing. So if you think about how it plays out for retailers and for the margin inside a place like Staples Center, something like 20 hours of the day, it's empty. It's dead. There's nobody there but staff, and staff know better than to buy food at Staples because it's too expensive. But when you show up, they know if it's a Lakers home game, they can jack the prices, and it's all digital signage, so they can adjust it accordingly, versus a Clippers game, which has a poor, in general, socioeconomic status. Gets better. What they were kicking around but haven't done, one of the original concepts for this, which I thought was hilarious, is they start having map suggested orders. What's your next purchase? So you're 2-3 beers in, your next purchase is something salty, right? Because you've got all the alcohol in your mouth and you're like, I should have some chip. And they will ping your phone to say, you really want something now. Probably nachos. And they will start, well, you're 3 beers in. Like, my phone knows me. This is awesome. Well, the next step after that, logically, if you think about it, if you don't care about people's privacy and you're being kind of unethical, dude's 3 beers in, 4 beers in. We're going to jack up the price of the next beer. He won't even notice. And that would be the next logical step for what you can do with personalized pricing. You get to find out what kind of demographic or psychographic people are, and you can map the profit margin specifically to whether somebody's a cheapskate or is there on business. All of that starts to play out, and that's incredibly interesting when you think about the data set you'd need. So I want to go through some personalized information for you. A lot of retail companies actually make more money off their financing arm than they do off selling you stuff. Think about Canadian Tire credit cards, right? So what I want to do is just get a sense of the room and show you how technology is playing out. Okay, everybody put your hand up. Just everybody put your hand up. So what I want you to do is tell me whether you would give this data if you needed a loan, okay? So the first one is your payment history to utilities and cable companies, right? If you want a loan, you're going to give them your utility bill, whatever. Like, it's already probably known. Equifax has already leaked it to the Russians and everybody else anyway, so what does it matter, right? Like, it's out there. It's on the dark net. You don't care. So everyone's hand's still up good. So how about anything? It's a business. How about all about your supplier invoices, what your time to payments are, whether it's 90 days before you get your bills paid, days outstanding. Would you give your supplier data to a bank? Or a alternative planning corporation might be a better way to phrase it. Okay. How about data from your phone? Would you give the telemetry data from your phone about when you charge it and where it is? Anyone? People in other countries are using the telemetry data from mobile phone networks to offer individualized, personalized loans because it correlates really well to whether you're trustworthy. You know why? Because if you do things like let your phone go all the way down to the bottom and it's frequently going to power out, you're probably not going to pay your loan back on time. So they have thought through all of these data points and done correlation analysis to check. There's also like, oh, look, this person's going to a peeler bar at 3 in the morning, also not paying back his loan. So they have thought through this data, the GPS data plus the personal behavior data, to work out what you should do from finances. So I see nobody's got their hands up anymore, so nobody's getting a loan? Okay, I'm going to walk you through the next bit of IoT payment information, which is kind of fun. GPS and Fitbit. So there are multiple health and life insurance companies that are already offering Fitbits for corporate insurance plans to be able to change what your premiums are going to be based on the health and the activity levels and the delta from when you got the Fitbit to later. So if your company suddenly has, especially in the States, which matters more than here for HMOs, if your company insurance plan all of a sudden hands everybody Fitbits, they want you to walk more for the next 90 days because their premiums drop because you're healthier and you're less likely to die. Or worse than dying from the point of view of the insurance company, to be in the hospital for more than 48 hours, right? So all of this is a problem, but that's a data set that people are using in real time. Then we get to even more fun stuff. Social media. Would anybody in the room give their social media graph out to get loans? And again, in Russia and some other Central European companies, as well as parts of China, this data is being used to give out loans. Because if your friends don't pay back their loans, you're not going to pay back your loans either. If you have trustworthy friends, then you stand a better chance of getting your loan. And the last one, which I think is hilarious, is would anybody give out their browser data? And I'm like, no, I don't let my wife see my browser data. Like, why would I let anybody from a bank see it? So this is where financial services is going. It's using data, and the data exhausts from all these physical assets, which is Internet of Things, to give you loans. And that leads to the next thing, which is the abstraction of how retail will work. So the rise of the connected product. And going back to the maturity model, this is where you start thinking about corporate vision, how that interplays with technology and data. Kaiser makes air compressors, right? You want to use a jackhammer? Get one of these. Traditionally, they sold them. Then they moved to leasing them. And they thought, after hiring a bunch of MBAs, it's like the classic thing. Nobody wants to buy a drill. People want a hole in the wall to hang things. People don't want to buy one of these. They want the jackhammer to work. So now they sell, through the connected technology, the fact that this Kaiser actually has connectivity in it, you buy just the air you used. That's it. Like, that's how you pay them. You don't need to have a capital asset anymore. You're getting it, you're picking it up, you drill your holes, and you're going to get a bill for the exact amount you use it. It's a connected product. So it solves the problem from the consumer. They don't need a capital asset that sits unused for something like 95% of the time. But on the other hand, they can mark up the bill as needed, depending on what they need to do to pull off profitability. So that's retail. Let's move on. We've got lots more to talk about. Cities. And you're like, why am I talking about cities? Well, cities are huge. For starters, City of Toronto has a $10.5 billion budget this year for its operating budget alone. The capital budget is expected to be $26.5 billion over the next 10 years. So they are your consumers if you're in an enterprise. They also set the rules. If you're in mortgage financing, they set zoning rules that you need to care about. They're the people who do property inspection for Greenwind, right? So they're the people who are going to come by and think about the houses. So they set the rules. They buy a ton of your stuff. They're incredibly important. And this is Quayside, which is down by the waterfront. So that's kind of the foot of Parliament and Queen's Quay in Toronto, if anybody knows the area. And I'll bring up why I have this picture in just a little bit. So they have use cases as well, except their use cases are driven by the political factors, like, can I get reelected? There's roads, there's transportation, there's energy, infrastructure, public safety. Toronto Public Service, the police service, $1 billion budget this year. That's a 2017 budget for the police service. That buys you a lot of connected toys. So when you think about IoT and how that plays out, these are all the IoT-related use cases for a smart city. And so this is Barcelona, which I unfortunately built this slide before the Catalan referendums. It might not be the best city to pick anymore. There's been a little bit of political disturbance. They're one of the first ones to get into smart cities. And why is because after the Olympics, they had a fiber optic network. They had already installed it because they had the Olympics. And so they started throwing everything they could at it to see what made sense. So on their street lights, which are all LEDs because that drives cost savings versus traditional cathode ray, they actually throw more and more sensors. They have noise meters, they have pollution meters, they have moisture sensors, they have traffic, pedestrian sensors, all sitting on top of the infrastructure. And the infrastructure to them isn't just connectivity, it's the street light post. That street furniture, as the city would call it, is actually a key tool for their police, for their roads, for the public works, for the Parks and Rec department. The moisture meter that I mentioned there lets them determine whether the trees need to be irrigated. Do I need to water or not water is determined by the moisture sensor sitting already on other infrastructure. So it's kind of what you think about the evolution of the city center is already here, right? We just don't happen to necessarily have it. But we do have some other cool stuff. Barcelona doesn't have these. Barcelona has many things, like Las Ramblas. We have snowplows. Did you know that every 400 series highway, the snowplow is connected already to the ministry? They need to send near real-time data to the ministry to keep their contracts. So they have GPS locations that are connected to the blade. When the blade drops, it sends a message to the ministry, so the ministry knows whether the 400 series highways started to be cleaned at that exit or where it started to be dropped. They also let them know exactly how much brine was deployed or salt was deployed in real time. So it's pretty funny to think, like the internet of snowplows. It's already here. And then we move to other stuff. So part of cities is culture and tourism. This is a museum. And what I wanted to bring up here isn't so much that beacons are in museums. That's pretty obvious. It's that IoT is not just code and computers. It's not like databases. So the anecdote that was really interesting when I was talking to somebody who was explaining how Internet of Things worked at their particular gallery was they wanted to do augmented reality. They had the board of directors on board. They were very excited. They were going to have a new experience for everybody. So they brought in a special type of beacons. And you're going to bring your phone up and it'll tell you more about the pictures in this gallery. And you could hear like Rembrandt's backstory or whatever. Well, the problem was the adhesive at the back of the traditional beacon was far too volatile for any of the artwork in their gallery, so they couldn't use it because the curators forbid that because it would degrade the paintings. So like, okay, well, we'll find a different adhesive. So when they launched it, the beacons were falling off the wall because the double-sided tape didn't work. So when you think about your problems as a CIO, I bet you haven't thought about double-sided tape being a problem. But in the world of the Internet of Things, it is, because it's a physical object in a physical world that will have weather conditions. CN Rail uses things that have to get through a winter in northern Alberta. Well, you need to think about power. You need to think about insulation. All these things start to matter because it's a very different world than just code computers. Speaking of which, connectivity, the previous group were talking about some stuff. So you have requirements that will vary depending on what kind of connected object you want. So if I think about connected cars, they need to be near latency. You're driving fast, you don't want to crash. We'll have autonomous cars that need to be incredibly low latency. Well, smart grid, yeah, it's not really an issue. They just want to know basically, ping, how much are you using to a gateway, it's fine. But on the other hand, they don't want to go back to that meter ever again. So that needs to be a super low power consumption for the connectivity. Whereas a car, it's hooked up to a battery. What does it care? You're going to refill it anyway. So the requirements when you start thinking about how connectivity plays out for your specific use case, going back to that word again, your specific use case will have very different requirements across these different 6 or 7 different requirements. I'll give you an example in the real world of how this plays out. These are the humble baggage carts. And baggage carts aren't sexy. We don't think about them until they don't work or they lose our luggage. At Schiphol Airport, which is it's the busiest airport in Europe, they had an issue where they kept not being able to find the baggage carts. So they're like, great, we'll just put a tracker on it. Can't do that because of radio frequency interference with planes. And if you remember not being able to turn on your plane, they take it pretty seriously about radio frequency interference at airports. So they couldn't use a whole bunch of different things. And they've got 27 kilometers they've got to deal with because it's a giant airport. So you don't necessarily, you're not capable of using a whole bunch of different classic technologies. And eventually what they did to work out where the baggage carts were, have they been maintained, are they at the right gate, was throw a mesh network at it. So every baggage cart can talk to every other baggage cart and eventually daisy chain its way back to the actual gate where there's actually a gateway, which gets confusing between airport terminology and computer terminology. But by using a different thought process about the requirements needed here, which is RF problems, They think through their problem. And going back to cities for a second, so this is the Minneapolis Bridge. It fell down. That was not good. And it's not good for a whole bunch of reasons, one of which obviously being that people passed away. But the other thing is, it's a leading indicator. The US Society of Engineers estimates that there's something like, I think it's 55% of all bridges in the US are substandard at this point in terms of their maintenance. This is a precursor to what is likely to happen to all of our bridges as well. So the civic infrastructure that you rely on to get to work, but also your trucks to get to their clients and such, is literally falling around. It was built in the 60s. It's not doing very well. Rebar and salt don't make for fun mates. So they rebuilt it. But when they rebuilt it, they wired it. So this is a wired bridge now. And what they do is they send telemetry data to the engineers to track all the progress of the factors that might lead to further corrosion in the future. Which is really interesting, because then it means that they get a better sense of whether they need to send a maintenance crew when they really need it, or do they not need it. And we think, we often talk about Canada being, not like the US. We don't have to worry about Trump and all these other factors. Well, this is Montreal. So for all of you guys who are going to commute back through the Dorval Airport, this was about 6 kilometers from the highway you're going to be on. Right? So this stuff really matters, that the physical infrastructure we're on is not reliable, and we don't know whether it's reliable or not because it's not connected. And that's underneath the Gardiner. So for all of you who live in Toronto, the Gardiner is dropping concrete, and we don't know when the next piece of concrete will fall down. We could if we wired it or wirelessly connected it, but at the moment we don't. And I'm from Ottawa, so I'm not going to pick on Montreal and Toronto without picking on Ottawa. That's not supposed to happen, right? Like that's kitty corner from Parliament. You're not supposed to have a 100-foot deep hole in the middle of Sussex Avenue. But again, our infrastructure is decaying and degrading, and there's an opportunity to improve it through IoT. This is Toronto again. This is Jane and Finch. And so a few years ago, there was a giant microburst came through. And what we should have known, if you're the city, you should have known all this data. You should have known that the gas main was at risk of blowing up. You should have known what the water level was in real time. We should have known that the water main is now broken, and there's a whole bunch of apartment buildings there that have no water at all, no running water for days. We didn't. But all of this is now possible. So I'm going to go back to a second to this picture. So last week, Alphabet, which is the holding company for Google, one of their divisions called Sidewalk Labs signed a deal with the city of Toronto. And their goal is to make that little blue dotted area the city of the future in Toronto. So they're going to spend hundreds of millions of dollars to see if they can make that into a smart city. And the smart city, in their perfect little cartoon vision of it, it looks wonderful. But the key thing from our point of view, for people in this room, is it's actually driven by the Internet of Things. So the garbage is going to be powered by robots under the roads, underneath the conduits. If we look at the public transportation, autonomous. The cars, autonomous. Right? The whole point for Google, why they get into this, is Google's mission is to organize the world's information and to make it available. And also sell ads against it. But that part's like really small font. If we think about how this plays out for the waterfront in Toronto, it's organize the world's physical information, not just digital information. That's the future of smart cities. The problem is, if you go far enough down that road, it gets really creepy really fast. So this is what China is doing, its public security agency. And one of the things to think about is they are recognizing every vehicle, tagging it against who should be on it, and using facial recognition to make sure it's the right person, which makes it very hard for people to fight repression or any of these other issues. So all of a sudden, the Internet of Things can be used, if we go back to vision, people, process, technology, data, it can be used for evil as well as good. And you're like, okay, well, that's cities, they're easy. Let's think about something where people get dirt under their fingernails, where people have a shower after they get off their shift, not before they go to work. So we think about mining. So mining, again, is transforming. Mining is becoming digital. This is the component, again, that relies on connected sensors. Lots of use cases for the future of mining and resources are all going to be digital. And you think about it, it is a dirty world. You're way underground. How do we connect these people? We need to connect them. And one of the reasons is people die mining, right? You don't get a lot of programmers dying except from having too much Red Bull. When you think about being a miner, people die underground. And one of the things they die from is self-inflicted problems, like a blast going off when people are still in the vicinity. That hasn't happened in Canada in years, but in lots of places around the world where Canadian mining firms own and operate mines, that does still happen, like Chile, like Romania. So Goldcorp and Barrick Gold are the two ones that I know the most about. They have actually put sensors on every employee who goes underground. They also put sensors along the mine shafts. so that they have a three-dimensional view of the world in terms of where every employee is in case there's a problem with air quality, in case there's a problem with the equipment, the lift to bring them up. All these factors, they know where they are, so they don't have to do a repeat of that Chilean incident where you had, whatever it was, 27 miners underground for basically a month. So the goal here is, how do we make the employees safer, which lowers our cost and makes us a better mining company? But once we've got the connectivity already in there, the infrastructure, why not throw everything else at it? So now all their hard equipment, they can do predictive maintenance on. Does it need service? Does it not? They can start working out whether there's a problem with tools. Because if you've gone a kilometer underground and you realize that your drill is out of battery, that's a waste of time. Because it's going to take you an hour plus to get back up to the surface to get something new. So now all the tools become connected as well. And mining isn't just drilling and digging and dirty stuff. It's actually like process manufacturing. So one of the neatest uses of the Internet of Things that I've heard of, how many people here have Shazam on their phone? Anybody have Shazam on your phone? Right, it's like magic, right? It's like that Asimov quote about any sufficiently futuristic technology is indistinguishable from magic. This is Shazam for pumps. So what they have done is they have approached Johnson Controls, Siemens, Philips, all the industrial manufacturers. And they sit there with recording equipment and they correlate what the sound should be versus what has gone wrong. So they know from the sound, just like an old-time worker might be like, that's not sounding right. They actually know that, they pump it to the cloud, and then they can say what's wrong with it. Is it cavitation, right? Or is it aeration? Which side of the coin is our problem today on this particular pump? Which then lets them do predictive maintenance. You're not just maintaining them every 60 days because that's what the piece of paper says. You're maintaining them in real time because they either need service or they don't need service. So it lets you change how you think about your maintenance budget as well. And it becomes sort of, Shazam for industrial equipment. And the other thing about code and computers versus IoT, so this is the long-tailed great Australian rat, bizarrely enough. In Australia, one of the mining companies had, on their large drill project, thought, why don't we wire everything instead of going completely wireless because it was out of cell coverage? Yeah, well, these guys really liked the coating on the coaxial type cables and would eat it and gnaw through and then get electrocuted and die on top of them. So they ended up not being able to use that type of connectivity because the rats were eating them. In Canada, we've had issues where porcupines were doing that. The porcupines love rubber, right? So they see a gasket type thing and they just start gnawing on it. So then you all of a sudden need chicken wire for your high-tech industrial gear. So again, the Internet of Things is not the same as just putting another server on a rack. You're going to have cost associated with servicing it and thinking through what the physical implications are of having expensive gear in the wild. And that would be the problem for this one. The last thing I want to think about with this resources really quickly is we often kind of, in Ontario, we've got the banks, we've got government, we've got healthcare, we've got high tech. If you think about the future of Canada, how much money the oil sands has made, it's tremendous. And the oil sands, they're no dummies. They are further ahead with autonomous vehicles than Ontario. Suncor already has a fleet of haul trucks that are self-driving cars, right? They can haul somewhere in the order of magnitude of almost 400 tons per load. And what was happening was they were paying their current drivers over $250,000 a year to drive them at about 10 to 15 kilometers an hour. That doesn't make a lot of sense financially. They're not that skilled. They're not going that fast. It's a private road. It's a controlled road. So Komatsu, Suncor, and a number of other players have basically wired these trucks to make sure that they have distance from each other. They follow all the rules. There have been issues in the past of oil sands where people fell asleep in the middle of the night and have driven over trucks. Nobody died, but if you see one of these drive over a Ford 150, it's fantastic. It looks literally like somebody has squashed it like a pop can under a wheel. And so the upside of having LiDAR in this means you're not going to drive over a $100,000 truck by accident in January when it's snowing. The LiDAR knows the truck's there, right? So all of a sudden, we're starting to see industrial companies like mining companies in the oil sands using self-driving cars. And when they can do it, what's next for drivers? So I want to bring this back home again, bring this around. I know we're running out of time. What are you guys going to do? Like, what's the plan for everybody in this room? So I have a few thoughts. One is, get on it. This is an interesting chart we pulled up from this year's survey data of Canadian companies. This is Canadian data only. And when we correlated or did a crosstab actually, not correlation, when we did a crosstab of how fast are your revenues growing, that's that 10% top bar that's circled in red. Hey, they even gave me a laser. So when I look at this fast growing, you can see almost 80% of those already have multiple Internet of Things use cases in production today. But you look at the flat companies, the companies that see no change in revenue, yeah, only 62% of them are doing something. And when we've looked at companies that have adopted the Internet of Things, it's like Pringles. They don't eat just one. So on average, companies that have already adopted the Internet of Things are up to 3 use cases that have been adopted already. So we're starting to see the virtuous circle for the winners move even faster, and the laggards go even slower. The next thing I want to point out is, when you think about how to go ahead with deploying your Internet of Things, people have often tried to roll their own, right? Like you think about how people want to move ahead or do custom dev. IoT is really complicated. You've got everything from edge devices, you've got edge gateways, you've got all the software stack, whether that's your applications, your security. Then you've got the issue of IoT platforms, right? Do you want to know what the telemetry data on your physical sensor is, not just whether it's working and in place, but like what's the battery life of the sensor? So all these components are complicated. And I mentioned already the connectivity. So when you think about how your corporation or organization is going to launch their IoT initiatives, it's worth thinking through that this is going to be a combination of vendors to get it done faster. You're going to want to think through how other players in other regions of the world have already done this, and basically think through how to do that better. The next component is the technology's here, right? The stumbling block for how Canadian companies will struggle with the Internet of Things is not the technology. In general, it's the vision. And that's what this maturity curve of whether you're running with it or whether you're just learning. The vision, are people going to use it to do what they've already done but marginally better with a few less errors? Or are they going to think about how to make this different for their actual business model? Will you start having data as a service? Will you think about a connected product? Or selling air as a service? That's hard. And the vision right now in Canada is we'd like to make a few less mistakes every year. That's currently where the Canadian vision is. It's like golf. If I can just chop off a few for my handicap, that'd be great. The other sticking point is processes are cemented in concrete. Process is the hardest part to change here. And so when you think about how this will play out, you need to bring together all the stakeholders. And by all the stakeholders, what I mean is these use cases will drive out changes, not just where you think you've deployed the IoT, but beyond. If you launch a connected product, finance is going to want to know about it. Why? Well, you've just made a commitment to all of the customers who buy that. Say I think about LG or Samsung. They're selling connected fridges now, right? You've got your giant tablet screen in the middle, and it's connected. The average lifespan of a fridge in Canada is 14.5 years. So Samsung and LG have made a commitment, unspoken, to their customers that they will commit programmers and coders to secure and update and patch that software for 14 years from now. So do you think they have a budget for that? Probably not. So finance needs to think through this as well. But marketing is going to get data kicked to them they've never had before. Instead of just having focus groups, they're getting real telemetry data. How does our product get used in the field? And that will make them rethink all of their campaigns, right? Because the data is sending the data back not just to its user, but to the company as well. The service team can rethink their whole model because now they know when and where it breaks down. So can you make a guarantee? Rolls-Royce is now guaranteeing uptime on their flights. It's called Total Care. 50% of Rolls-Royce's aircraft engine revenues comes from Total Care, which is a guarantee of uptime. They guarantee the maintenance to all of the airlines who buy their engines now. So you're not buying an engine, you're just buying a guarantee that your engine will work. And that comes from the IoT. So all this feedback loops will change the processes and the vision of your company, but you're not necessarily sure how. And that's why I'm saying the good artists copy and great artists steal. There's already examples out there. Learn from them, listen to them. Don't just look in your sector. Look at every sector, look at all the other countries, because there's commonalities between cities and between your company. There's commonalities between Europe and Canada. And if you can be a leading adopter of what somebody else has already spent the hard intellectual effort of thinking through, bring it to Canada first. So with that, I need a glass of water, but also, hopefully I will be around the rest of the day if anyone has questions, or beer and questions. The latter is better than the former.